This ed puzzle covers Unit 2 for constant velocity. Which of the following quantities is a vector? Distance, speed, density, time, or displacement? Here the only vector is displacement. It is the only quantity that includes direction. The other four all have magnitude only, which is just a numeric value and no description of direction. What are the metric units of velocity? Answer here is meters per second. Right? Those would also be the units of speed. Meters, on the other hand, measure a distance or displacement. Seconds would measure time. Seconds squared we have not dealt with at all. How can you graphically find an object's velocity? The answer here is the slope of a position versus time graph. All right. This gives you rise over run, which would be your change in position over change in time. And change in position is your displacement. So in another way, it is simply getting the amount of meters you move in this certain number of seconds. How can you graphically find an object's displacement? This would be D, the area beneath a velocity versus time graph. For our unit so far, all our velocities are constant, which would lead to rectangles, where the height of the rectangle is your velocity, and the width of your rectangle is the elapsed time. So when you multiply velocity and time, that gets you how far you travel, or your displacement. An object moves forward 6 meters in 3 seconds and then moves backwards 8 meters in 2 seconds. What is its overall or total displacement? Be negative 2 meters, right? Displacement is your change in position, and you would wind up 2 meters behind where you started. Right? If you chose 14 meters, you would have been describing the object's total distance covered. Okay. Same motion, but now the question is for the object's average velocity through the entire trip. All right, and velocity is a vector, right? So it includes direction. So it is your displacement over time, which was negative 2 meters, but that was covered in a total of 5 seconds, which is equal to negative 2/5 or negative 0.4 meters per second. All right, a position time graph is given on the side here. According to it, what is the velocity at 5 seconds? We can find velocity from the slope of this position time graph. So at 5 seconds, right, we are in this region here. So if we do our rise over run, we go 40 meters, right, backwards in 1.5 seconds, which leads to a slope of negative 26 2/3 meters per second. According to this graph, what is the displacement in the entire 6 seconds? Hopefully you didn't get fooled here, right? We're not taking areas underneath this graph, right? It is not a velocity time graph. All right, we start at a location of 20 meters, we move forward to 60, then we move backwards to 20, and we wind up in the same location that we started. Hence, our overall displacement is 0. Now we have a velocity versus time graph. All right. What is the velocity at 1 second? just look at the graph, right? At 1 second, we are moving at 4 meters per second. Now, using the same graph, what is the displacement in the first 2 seconds? This is where we use the area underneath the velocity time graph. So we have 4 meters per second for 2 seconds, right? 4 times 2 would lead to a displacement of 8 meters. What is the displacement in the first 6 seconds? Same method. Notice here we would get positive areas when the velocity is positive. So we'd get positive 8, positive 2. Then in this section, this 1 second moving at negative 10 meters per second, this area would be negative 10. All right, so this is 10 meters forward, 10 meters backwards, would lead to an overall displacement of 0.